Hey everyone, welcome back to the channel. Today we're going to talk about a very important yet simple concept in engineering, strain energy. Whether you're from civil or mechanical background, this is something you must understand clearly. So let's make it super simple and interesting. Let's start with the basics. Imagine you have a spring. When you pull or compress it, you apply a force and the spring resists. Now, the energy you use to stretch it doesn't just disappear. It gets stored inside the spring in the form of strain energy. So in simple words, strain energy is the energy stored in a body due to deformation under applied loads. This happens when a structure is stretched, compressed, twisted, or bent. And the good part, when the force is removed, the body tries to regain its original shape by releasing that energy. Think of a rubber band. Pull it, it stretches. Leave it, it snaps back. The stretching part stores strain energy. The snapping back part releases it. So just like a rubber band, structural elements in buildings, machines, and vehicles store and release strain energy. Now, why is this important for engineers? In civil engineering, when we design beams, columns, or bridges, we must know how much energy they can safely absorb during loading before they deform too much or fail. In mechanical engineering, components like springs, shock absorbers, and even machine frames depend on this energy behavior to function efficiently. It's especially important in earthquake engineering, crash analysis, and fatigue testing. Let's get a bit technical, but not too much. The basic formula for strain energy in a linear elastic material is U equals a half times stress multiplied by strain multiplied by volume. Or if you're working with axial loads, U equals square of P times L over 2 times A multiplied by E, where P equals load, L equals length, A equals area, E equals Young's modulus. The unit of strain energy, it's joules, J, just like any other form of energy. Let me give you a simple example. Take a steel rod of 1 meter with a force applied at its end. As the rod stretches slightly, it stores energy. If we know the load, dimensions, and material properties, we can calculate the exact amount of energy stored using that formula. This helps us in knowing how much load the structure can safely take before permanent deformation. Now that you've understood the basics of strain energy, here are a few next-level topics to explore. Castigliano's theorem. It is used to calculate displacements using energy methods. Strain energy in bending and torsion. It is important for beam and shaft design. Resilience and toughness. It measures of energy absorption before failure. Finite element method, FEM, where strain energy plays a huge role in simulation. All of these are super useful in real-world design and analysis. I hope this video made strain energy easy and fun to learn. If it helped you, give it a thumbs up, and don't forget to subscribe for more such simple explanations on engineering topics. Drop a comment if you have any questions or if you want me to cover any of the advanced topics I mentioned. Thanks for watching, and keep learning.